Discriminant and roots. Understand the discriminant and its role in determining the nature of roots. Apply the quadratic formula to find roots of quadratic equations. Interpret the significance of real and complex roots in problem solving. Goals for this lesson. Understand the discriminant and its role in determining the nature of roots. Apply the quadratic formula to find roots of quadratic equations. Interpret the significance of real and complex roots in problem solving. Basic rule. Step 1. Identify the quadratic equation. Recognize the standard form of a quadratic equation, e.g., ax squared plus bx plus c equals 0. Step 2. Calculate the discriminant. Use the formula d equals b squared minus 4ac to find the discriminant. Step 3. Determine the nature of the roots. Analyze the discriminant. If d is greater than 0, there are two distinct real roots. If d is equal 0, there is one real root. If d is less than 0, there are two complex roots. Repeat after me. Example 1. Solve the equation x squared minus 4x plus 3 equals 0. Step 1. Identify a equals 1, b equals negative 4, c equals 3. Step 2. Calculate the discriminant. D equals negative 4 squared minus 4 times 3 equals 16 minus 12 equals 4. Step 3. Since d is greater than 0, there are two distinct real roots. Step 4. Use the quadratic formula. X equals 4 plus or minus 4 times 2 times 1. X equals 4 plus or minus 2, x equals 3 or x equals 1. Example 2. Solve the equation 2x squared plus 4x plus 2 equals 0. Step 1. Identify a is 2, b is 4, c is 2. Step 2. Calculate the discriminant. D equals 4 squared minus 4 2 equals 16 minus 16 equals 0. Step 3. Since d equals 0, there's one real root. Step 4. Use the quadratic formula. X equals negative 4 plus or minus 0 over 2 squared. X equals negative 4 over 4. X equals negative 1. Example 3. Solve the equation x squared plus 2x plus 5 equals 0. Step 1. Identify a equals 1, b equals 2, c equals 5. Step 2. Calculate the discriminant. D equals 2 squared minus 4. 1 times 5 equals minus 16. Step 3. Since d less than 0, there are two complex roots. Step 4. Use the quadratic formula. X equals negative 2 plus or minus square root of 2 times 1. Common mistakes include: solve x squared minus 2x plus 1 equals 0. D equals negative 2 squared minus 4 times 1 equals 0. Roots: x equals 2, x equals 1. Solve 3x squared plus 6x plus 3 equals 0. D equals 6 squared minus 4 times 3 equals 0. Roots: x equals negative 1, x equals negative 1. Correct versions are: solve x squared minus 2x plus 1 equals 0. D equals negative 2 squared minus 4 times 1 equals 0. Roots: x equals 1, double root. Solve 3x squared plus 6x plus 3 equals 0. D equals 6 squared minus 4 times 3 equals 0. Roots: x equals negative 1, double root. Mini practice. Choose the correct form. 1. Solve for x. X squared minus 6x plus 9 equals 0. Answer: x equals 3. 2. Which value of x satisfies the equation 2x squared plus 8x plus 6 equals 0? A. X equals negative 3. B. X equals negative 1. C. X equals negative 2. Answer: A. 3. Solve x squared plus 4x plus 8 equals 0. A. X equals negative 2 plus or minus 2i. B. X equals negative 2 plus or minus 4i. C. X equals negative 4 plus or minus 2i. Answer: A. Pro tip: always calculate the discriminant first to determine the nature of the roots. Use the quadratic formula carefully, ensuring you account for both the plus and minus options. Summary: the discriminant helps identify the number and type of roots of a quadratic equation. Real roots occur when the discriminant is non-negative, while complex roots arise when it's negative.